Okay, Year 12, good morning. I hope you're all well. We're going to go through dynamic equilibrium. This shouldn't take too long. I'm going to use all the same examples that are in the book that you've already read. So this is just a recap to make sure you're thinking about it in the right way to confirm what you already know. Okay, so um, firstly, we need to differentiate between reversible reactions. So this equation on the left, this is not reversible, indicated by the single directional arrow, and this equation is reversible, indicated by this double-headed arrow. So what does that mean? So not reversible means that this equation goes to completion. So all of the hydrogen reacts with all the oxygen to make water, and nothing goes in the other direction. Okay, so it only happens in the forward direction. All right, so my water is not going to be able to react back into oxygen and hydrogen. Okay, and that should be fairly obvious. The water lying around your house isn't doing that. Okay, now over here, this is the Haber process, which you should have seen at GCSE, and we'll see a lot more of in a bit. This is reversible, and what that means is that the reactants, nitrogen and hydrogen, react together to make ammonia, but the ammonia is also able to form nitrogen and hydrogen, so it's able to go in the reverse direction as well. So generally reversible means that there are products can react to form reactants. Okay, and that's what we're talking about. All right, I don't want you saying things like, "Oh, reversible reactions are reactions that can be undone." All right, that's not the way to think about it. It's that the reactants can react together to form the products, and also the products can react together to form the reactants. Right. And then what we mean when we talk about dynamic equilibrium, well, the word dynamic is the constant motion, so it's this idea of not being stationary. So the danger is that you might look at this equation and you think, right, well, okay, I've got 1 mole of nitrogen and I've got 3 moles of hydrogen, and they just stay as they are. And I've got 2 moles of ammonia and they just stay as they are, and then nothing happens. Okay, that's not correct. So all the time, these reactants are reacting together to make ammonia, and all the time, ammonia is forming hydrogen and nitrogen. So that's what this dynamic part means. Okay, it means that the forward and backward reactions are both happening. And then equilibrium. What does equilibrium mean? So you are right in thinking that these don't change. They don't change in quantity. So even though they're always forming ammonia, because ammonia is always forming nitrogen and hydrogen, the quantities don't change. And that's what we mean by equilibrium. So the quantities are not changing. So even though these reactions are both happening all the time, this is a dynamic situation, the quantities are not changing. And that's because at equilibrium, the rate of forward and backward reactions are equal. Okay, now when we start talking about the Chatelier's principle in a moment, we're going to be talking a lot about position of equilibrium. Okay, and what do we mean about position of equilibrium? So this is what it is. If the position of equilibrium is to the right, okay, it means we are producing more products. And if the position is over here to the left, it means that we are producing more reactants. Okay, now that's everything set up nicely now, so we can start talking about the Chatelier. If you need to copy any of that down, you can pause it, copy that down. Otherwise, let's carry on. So, first of all, the Chatelier's principle, you should have the definition from when you were doing the reading in the textbook. I'm not going to go through that. I'm going to go straight in and look at the first situation, which is a change of concentration. Right, so what we have here is, this is an acid. Okay, so there is an acid reacting with this to form this and this. All right, now I'm not going to worry too much about what those things are, because what we're thinking about today is just the effect on equilibrium that changing these quantities can have. So, situation number one, I'm going to call this A, okay, is if I add more acid. So what happens if I add more acid? Well, adding more acid increases the concentration of H+, because acid's going to be H+. If I put more acid in, I'm going to get more H+. Okay, so I've increased this quantity here. So the equilibrium is going to want to shift to minimize that change. Okay, so it's going to move to decrease the concentration of H+. Okay, so how can the equilibrium move to decrease this? Well, it just needs to do the forward reaction. Okay, it needs to react more of the acid with this, so that will remove the acid and it will produce more of this. So what happens is it shifts to the right. Okay, and if I shift to the right, what happens is I produce more products. Okay, and that's it. So any of these, you can analyze it in 4 steps, more or less. So for B, for the second one, I want you now to think about what happens if I add NaOH. Okay, now sodium hydroxide is an alkali. What that's going to do, it's going to react with the acid, so it's going to remove the acid from the equilibrium mixture. Okay, and if I remove acid from the equilibrium mixture because it's reacting with my hydroxide, what effect will that have on the position of equilibrium and the quantities of products? Okay, have a go at that.